Dear students, so today let us we study about a topic explosives. In this explosives, let us we know what do you mean by explosive, what are the types of explosives and various examples and their methods of preparation and characteristics. An explosive is a reactive substance that contains a great amount of potential energy which can produce an explosion if released suddenly. So explosion always leads to or it is accompanied by the production of light, heat, sound and pressure. An explosive charge is generally measured quantity of an explosive material which may either be comprised of one ingredient or be a mixture of two or many ingredients. It means the explosive material may contain only one type of a material or it may contain the mixtures of many ingredients. The potential energy stored in an explosive material may be either a chemical energy or it may be a pressurized gas or it may be a nuclear energy. Suppose if it contains a chemical energy, the examples are nitroglycerin or grain dust. So the explosive material, so if it is pressurized gas, it may be a gas cylinder or aerosol. Then if it is a nuclear energy which may contain either uranium-235 or plutonium-239 as the fissile material. Explosive materials may be categorized as high explosives and low explosives based on speed at which they expand. The low explosive materials are generally the crackers. So generally we use in festivals, they're all the low explosives. So the high explosives, they make more damage. They are highly intense. These explosives are also categorized in another way as primary explosives and secondary explosives based on their sensitivity. Primary explosives are the sensitive materials that can be initiated by a relative small amount of heat or pressure. And these primary explosives will not do much damage and they are very sensitive. Secondary explosives are the materials that are relatively insensitive and these they explode when relatively higher primary explosives are used. A chemical explosion is a type of spontaneous chemical reaction that once initiated is drawn by or it is driven by both a large exothermic change and a large positive entropy change in going from reactants to products and propagates very rapidly. The meaning of this statement is, you have studied in the earlier class, if a reaction is to be a spontaneous, then it should have a negative free energy change and positive entropy change. That means the free energy must be less and entropy must be more, then only the reactants they turn into the product spontaneously. Similarly, if a chemical explosion is to take place, so it also should have the less free energy and more entropy. Explosive substances contain a large amount of energy stored in chemical bonds. Most commercial explosives are the organic compounds containing nitro group, nitrate group, and imino-nitro groups. After explosion, they produce generally nitrogen dioxide. Examples of this kind are nitroglycerin, trinitrotoluene, it's commonly called TNT, octogen, and then pentaerythritol tetranitrate, generally called PETN. And also you have nitroglycerin, nitrocellulose, and so on. Explosion may be in the form of decomposition, deflagration, or detonation, or exotic. So let us know the meanings of these things. Decomposition is nothing but it is a breaking of single component into two or more fragments. This decomposition also we have generally used the decomposition of calcium carbonate, which breaks into the calcium oxide and carbon dioxide. That is, a breaking of one material into two or more fragments is decomposition. During this process, lot of energy is released. Another is deflagration. Deflagration is subsonic combustion propagating through heat transfer. That is, hot burning material hits the next layer of cold material and ignites it. In another way, the deflagration means burns away rapidly. For example, if you start burning a paper, it continuously burns till all the paper burns. That is called the deflagration. Suppose if a cloth is there, in the cloth starts burning, it continuously burns, so till all the cloth gets burnt. This is called the deflagration. Detonation is a type of combustion involving supersonic exothermic front propagated by an explosive shock waves. So the detonation, another way, is nothing but explosion. The explosion is also called detonation. Now coming to the exotic. Exotic means it's a foreign material. Exotic. Exotic explosive materials, that means the materials that we buy from the other countries. These are called exotic explosive materials, which generally includes nuclear explosives, laser or electronic arcs. Coming to the characteristic properties of explosive materials. Explosive materials have a few characteristic properties. They include sensitivity. They are more sensitive. Once that sensitization is given, then the material gets exploded. After the explosion, it forms a stable material. Then they have very high power, performance, and strength. So these explosive materials have a character of brisance. That means shattering capability of high explosives. After explosion, the material gets shattered. These explosive materials have a definite density, they have volatility, and they also have hygroscopicity and water resistance. The hygroscopy means having some moisture in the system. These explosive materials are also toxic in nature and they balance oxygen and chemical composition. These are the some of the characteristic features of explosive materials. Now let us study some of the explosive compounds. For example, lead azide. Lead azide is a primary explosive. Its formula is PbN3 twice. Lead azide is a buff colored powder. It is used as detonator to initiate secondary explosives. That's why this is a primary explosive. This primary explosive is used as an explosive material to ignite secondary explosives. It is prepared by the reaction of sodium azide and lead nitrate in aqueous solution. The thickeners generally such as dextrin or polyvinyl alcohol are added to the solution to stabilize the precipitated product. The characteristics of lead azide, it includes: it is highly sensitive and stored under water in insulated rubber containers. It will expand after a fall of around 150 millimeter or in the pressure of a static discharge of 7 millijoules. Its detonation velocity, it's called the detonation velocity, is around 5180 miles per second. Ammonium acetate and sodium dichromate are used to destroy small amount of lead azide. Lead azide reacts with copper, zinc, cadmium or alloys containing these metals. Copper azide is even more explosive and too sensitive to be used commercially. Lead azide is considered to be a highly sensitive explosive and has been classified into the first group of the safety precautions. It is being more efficient than mercury fulminate, which is also a primary explosive. It requires high temperature for spontaneous combustion. So these are some of the characteristic properties of lead azide, which is an inorganic explosive material. Now coming to the another explosive material called pentaerythritol tetranitrate, commonly abbreviated as PETN. Pentaerythritol tetranitrate is a highly explosive organic compound belonging to the same chemical family as nitroglycerin or nitrocellulose. It has the chemical formula C5H8N4O12. It is prepared by reacting pentaerythritol with nitric acid in alcohol medium at low temperature, so that PETN precipitates, which is filtered, washed, dried and recrystallized to produce crystalline solid. It is stored in aqueous alcohol. Coming to the properties of this PETN. PETN retains its properties in storage for longer periods than do nitroglycerin and nitrocellulose. It is sensitive and detonated by an appropriate mechanical shock. It has been valued in both military and civilian applications for its shattering frame and efficiency. It is used by itself in detonators, blasting caps, and detonating prima cord. Roughly equal amounts of PETN and TNT mixture creates a military high explosive called pentolite, which is used in grenades, artillery projectiles, and shaped charge water heads, charge wave heads. When it is mixed with extremely powerful compound, that is RDX, in an appropriate solvent, it forms a plastic explosive mixture known as Semtex, which is valued weapon in terrorist bombing. Coming to the another very explosive material called RDX. The name RDX is not a chemical name, it is given by the Britishers, meaning is Research Department Explosive or Royal Demolition Explosive. The chemical name of RDX is cyclonite, which is a powerful explosive. It is hard, white crystalline solid, insoluble in water. It is sensitive to percussion. It is used in blasting caps. It is often mixed with other substances to decrease its sensitivity. The formula of the RDX, that is cyclonite, is O2N2CH2 thrice. It is classified as nitroamine, which is more energetic explosive than TNT. RDX targets the nervous system and can cause seizures in humans and animals when large amounts are inhaled. That means it attacks the paralytic, or paralytic attack will take place when RDX is inhaled more. It is most powerful and high explosive. That's why RDX belongs to secondary explosive material. As a military explosive, RDX can be used alone as a base charge for detonators. When it is mixed with other explosives like TNT, it forms cyclotoys. This is used for aerial bombs and in case of minings. So this is about the three important explosive materials. Now coming to the another phenomenon known as rocket propellant. Rocket works on the principle of every action has an equal and opposite reaction. This is the Newton's third law of motion. In order for the rocket to rush forward, something has to rush backwards. That one which rushes backward is called propellant. Some gases, they come out from it, and those gases, it is called propellant. Propellant is the material that spews out of the back of the spacecraft, giving it thrust or a push forward. Propellant is a kind of fuel which is burned with an oxidizer to produce large volume of very hot gas. These gases expand until they rush away the back of the rocket, making thrust. Sometimes the propellant is not burned but pushed directly out of the spacecraft, making thrust. Thrust is a force that makes to come out of the gas and moving the rocket in forward direction. In an ion propulsion, the propellant is made up of electrically charged atoms which are, which are magnetically pushed out of the back of the spacecraft. Rocket propellants contain a fuel and an oxidizer. Typical fuels used are kerosene, alcohol, hydrazine and its derivatives, and even liquid hydrogen. Oxidizers include nitric acid, nitrogen tetroxide, liquid oxygen, and liquid fluorine. Extremely powerful rocket propellant is liquid hydrogen. It has lowest molecular weight and burns with extreme intensity in presence of liquid oxygen. Propellants are classified according to their state, that is liquid, solid and hybrid. In liquid propellant, rockets, the fuel and an oxidizer are stored in separate tanks and are fed through the system of pipes, valves and turbo pumps to a combustion chamber where they are combined and burnt to produce thrust. Liquid propellant engines can be throttled, stopped or restarted once again. Liquid propellants used in rockets are petroleum cryogens and hypergols. Petroleum fuels used are refined kerosene, oxidizer like liquid oxygen. Cryogens are liquid hydrogen, that is liquefied gases stored at very low temperatures. Liquid methane, liquid fluorine and oxidizers used here are liquid oxygen. Hypergolic propellants include hydrazine and its derivatives, and oxidizer used here are nitric acid, nitrogen tetroxide and nitric oxide. We also have solid propellants, and these solid propellant motors are the simplest of all rocket designs. Examples there we use are nitrocellulose, nitroglycerin, ammonium perchlorate, etc. These propellants are held together by polymeric binders like polyurethane or polybutadienes, etc. Hybrid propellant engines represent an intermediate group between solid and liquid propellant engines. Here fuel is a solid and oxidizer is a liquid. Example, that is hydroxy terminator polybutadiene is the solid fuel used and liquid nitrous oxide is used as an oxidizer in this hybrid propellants. Now these are some of the slides which once again explains about the explosives. So in this slide I have shown a meaning of an explosive. Explosive is a solid or liquid substance or a mixture of substances which on application of suitable stimulus is converted in a very short time interval into other more stable substances, largely or entirely gaseous with the development of heat and high pressure. Here I have shown a meaning of a chemical explosive. So for a substance to be chemical explosive, it must undergo a chemical reaction that releases lot of energy, making the temperature and gas pressure rise rapidly. So these slides that shows the meaning of the explosion. Explosion results what? The explosion results sound, light, heat and pressure. And we have also studied, that is, the classification of explosives like low explosives, high explosives, blasting explosives, initiation explosives. Initiation explosives are nothing but primary explosives. Blasting agents, they are secondary explosives. This slide shows about the special application of the explosive. These are needed for controlled blasting, underwater blasting, and blasting of high temperature rocks. So here I have shown the military explosives. These military explosives are manufactured for specific purposes. Such explosive must be produced from cheap raw materials that are not strategic and are available in great quantity. Operations to manufacture them must be simple, cheap and safe. Density of explosives needs to be as high as possible. The diagram shows about a military explosive. We have the low explosives and high explosives. So the high explosives are generally secondary explosives which detonate when ignited in small quantities in open air. This group contains most high explosive used to commercial and military plastics like dynamite, TNT, PETN, RDX and tetril. So commercially, the dynamites, water gels, the binaries are generally used. These high explosives, once again, they are primary explosives and secondary explosives. Primary explosives are easily detonated, or detonated means they explode. Easily explode just by heat and a shock. Whereas the secondary explosives, they are insensitive to heat and shock, and they are normally needs to be detonated by a primary explosive. So to detonate the secondary explosives, we need primary explosives. In this slide, I have shown these explosives, primary and secondary, the examples. Lead azide, as I have said, lead stiplimate, the lead picrate, sodium azide, mercury fulminate, silver azide. These are some of the examples of the explosive which belongs to primary explosives. Okay, so the secondary explosives include the Simtex, then dynamite, TNT, urea nitrate, ETN, and so on. Of course, there are some tertiary explosives are also, they are not that much in use. Primary explosives, as I have said, the lead azide, lead stiphnate, mercury fulminate, they have the VOD values, that is the distance what they travel from the initiation. So the lead azide is having the VOD 6,745 feet per second. The next, the lead stiphnate has 17,000 feet per second. Mercury fulminate is having VOD value 14,780 feet per second. So once again, this slide explains the same. The examples of primary explosives, lead azide, lead stiphnate, so diazo, dinitrophenol, and so on. So these are some of the properties of primary explosives. The primary explosives detonate violently. They are used to detonate other explosives through a chain reaction and are often referred to as primers. The major ingredients of blasting caps and include lead azide, lead stiffenate, and diazodinitrophenol. These are rarely used in homemade bombs. Of course, the secondary explosives, these are used as main charge and sometimes as a booster for much less sensitive explosives such as info. Relatively insensitive to heat, shock, friction, and static electricity. These secondary explosives usually require the help of high explosives in order to detonate. Some of the least sensitive items cannot be detonated unless the detonation wave of the primary explosive is amplified by a booster. So this is also almost the same information is given in this slide. Here I have shown how a secondary explosive will be. Secondary explosives are relatively insensitive to heat, shock, and friction and will normally burn rather than detonate if ignited in small quantities in the open air. Dynamite and TNT, PETN, RDX are the examples of secondary amines. The diagram shows, so the first part, that is the A part of the diagram, is a sawdust soaked in nitroglycerin. The second part or the B part that shows protective coating surrounding the explosive material. The third part or the C is blasting cap. Fourth part or the D is electrical cable connected to the blasting cap. So this is how the explosive materials and explosive things are made. Coming to the rocket, the principle of the rocket. The rocket generates large amount of high pressure combustion gas in their engines, and this gas is ejected rearwards at high speed, providing the force that drives the rocket forward. The burn the fuel in space where no air exists, therefore an oxidizer is generally necessary here. So this is the principle of the rocket and the rocket propellants. In the first one, we have a liquid propellant. In the second case, it is a solid propellant. As we have discussed, the liquid propellant is having separate liquid fuel chamber and liquid oxidizer chamber. From these two chambers, there is a pump will be there, and from the pump, the two things, they come to the combustion chamber, and there the combustion takes place, and the lot of the gas will come out from the chamber, and that gas gives the upward thrust. And so the rocket moves up with the evolution of the gases. In case of solid propellant, so we have a solid fuel is used and we have an oxidizer. So these two, they burn in the combustion chamber and the gas will come out, that shifts or it gives the upward thrust to pull the rocket. So this is also a slide which shows almost the same principle as I have explained. So the thrust and gravity and drag, how it does and how the rocket moves. So the liquid rocket engine, how it will be, that only that part is shown here. So which is having one fuel chamber and another is oxidizer chamber. From these two, from the pumps, they come into the combustion chamber, they burn there and produce a gas. That gas will come out from the system, which gives the upward thrust, and that thrust so moves the rocket in the forward direction. So this is the diagram that shows how the rocket, it moves. That coming out, they are known as the propellants. So this is also another, the rocket, how it is moving and giving tremendous amount of the gas in the backward direction. Yes, the students go through these aspects and try to learn about this explosion.